Have you ever wondered what the difference between diesel and gasoline is? Both are derived from crude oil and utilized as fuel in a variety of engines. They have their unique traits and applications. In the next few moments, we will explore the chemical differences between diesel and gasoline. First, let's consider the chemical composition of these fuels. Now, both gasoline and diesel are classified as hydrocarbons, which means they're made from molecules of hydrogen and carbon. But here's where things get interesting. Gasoline is a cocktail of hydrocarbons, typically containing 8 to 12 carbon atoms per molecule. This composition allows gasoline to be highly volatile, which means it vaporizes easily, making it perfect for spark ignition engines. On the flip side, diesel is a bit more complex. It's composed of hydrocarbons with 12 to 16 carbon atoms. This makes diesel denser and less volatile than gasoline. And it's this property that makes diesel ideal for compression ignition engines, which rely on the fuel's self-ignition under high pressure. Now, why does the number of carbon atoms matter so much? Well, during combustion, each carbon atom in the fuel reacts with oxygen to produce energy. So the more carbon atoms in a molecule, the more energy it can potentially release. That's why diesel, with its higher carbon count, is often associated with more energy per gallon than gasoline. So you see, the difference in the number of carbon atoms leads to different properties and uses for these fuels. Now that we've covered the basics, let's summarize. Diesel and gasoline, both offspring of crude oil, vary in their chemical makeup. Gasoline is composed of hydrocarbons with 8 to 12 carbon atoms, whereas diesel carries hydrocarbons with 12 to 16 carbon atoms. This distinction in chemical structure influences their combustion process and the amount of energy they release. In essence, while they might seem similar, diesel and gasoline have distinct chemical properties that dictate their specific uses.